In this video, we're going to solve the system of simultaneous equation by matrix inversion. Now we have already discussed what is a simultaneous equation. A simultaneous equation is a set of a finite number of equations for which common solutions are sought. Now let us derive the formula for matrix inversion. So this is a set of simultaneous equations which has nth number of variables and nth number of equations. N out here can take any number. In this case, if n takes the value of 4, it means that there are 4 variables in this equation. Similarly, if n out here takes the value of 5, then it implies that there will be 5 equations. d1, d2 and dn are constant terms. Now we can rearrange this set of simultaneous equation in a matrix form. Now this matrix out here is a coefficient matrix which contains all the coefficients. Next, this is the vector of the variables and this is the vector of the constant terms. Now if you remember multiplication of two matrices, then we see that if you multiply the first row of the coefficient matrix with the first column, there's only one column, it is a vector. If you multiply this with this, we will get this equation out here. Now a11 times x1, a11 times x1 plus a12 times x2, a12 times x2 plus a13, that means this one, times x3. Then it goes on in this manner. Then finally a1n times xn, and this is equal to d1. So we see that when we multiply, we obtain the original equation. So we can arrange it in the form of a matrix. Similarly, the others also you can do by yourself. Now we can name the coefficient matrix and variable vectors and constant term vectors by some alphabets. Let us name the coefficient matrix by A, the variable vector by X, and the constant term vector by D. So Ax is equal to D, that is the coefficient matrix times the variable vector equal the constant term vector. So if we multiply both sides by A inverse, see out here we are multiplying both sides. On the left hand side I have multiplied A inverse, and on the right hand side also. If we multiply both sides, what we get is that now A inverse times A is equal to I. There's a property for it which we have discussed in earlier problems as well. So A inverse times A is equal to I. What is I? I is an identity matrix. Now I times x is equal to x. Why is that? Again, multiplication between any matrix and an identity matrix will yield the given matrix itself, that is identity matrix times matrix x or vector x is equal to x. So given any matrix, if you multiply it with an identity matrix, then the resulting matrix will be the original matrix itself. So this is the formula for finding the inverse of a matrix. Given any simultaneous equations of any number of equations, you can find it by using this particular formula. X, that is the uh, variable vector, equal A inverse times D. What is matrix A? Matrix A is the coefficient matrix. Let us solve a system of simultaneous equations of two equations and two variables. So we have two equations out here. First of all, when you get a set of simultaneous equations, you need to arrange it in matrix form. So the first matrix is the coefficient matrix. What are the coefficients? Coefficients of the first variable in the first equation is 4. Second variable in the first equation is 3. First variable in the second equation is 2. And second variable in the second equation is 5. What are the variables? The two variables are x and y. What are the constant terms? Constant terms are 28 and 42. Now we can see that if we multiply the first row with this vector, we will get the first equation. If you multiply the second row with the variable vector, we will get the second equation. 4 times x plus 3 times y is equal to 28. Again, if we multiply the second row with the vector variable or variable vector, we will get this equation out here. Let us give a name to the coefficient matrix, the variable vector and constant term vector. We'll name the coefficient vector by A, the variable vector by x, and the constant term vector by D. Now we know that x is equal to A inverse times D. This is the formula of matrix inversion for solving the system of simultaneous equation. You must remember this formula, and I've already shown you how it is derived. I've taken a system of simultaneous equation for nth number of equations and nth number of variables. So this is our formula. So we have to find A inverse out here. So now A inverse is equal to 1 by determinant A times adjoint A. We have already done problem on inverse of a matrix, so we have to proceed in the similar manner. Remember, there are two conditions. The first condition is that the given matrix must be a square matrix, which is evident out here. The coefficient matrix is a square matrix. The second condition is that the determinant should not be equal to 0. That is, it should be a non-singular matrix. So let us find determinant of A. It is a second order determinant. We have to cross multiply 4 times 5. There's a minus sign in between. 2 times 3. Let us do. Now 4 times 5 is 20, minus in between. 2 times 3 is 6. So our answer is 14. Is it equal to 0? No. Since it is not equal to 0, we have satisfied both the conditions. We have to write, since the value of determinant A is not equal to 0, matrix A is non-singular and A inverse exists. Again, remember, there are 4 steps in finding the inverse of a matrix. The first step is finding the determinant, which we have completed. The second step is finding the cofactors of all the elements in the given matrix and arrange them in a matrix which is known as the cofactor matrix. What is a cofactor? Cofactor of an element is the minor of that element, taking into consideration its positional sign. Now cofactor of A11, which is element 4, let us check its positional sign. 1 plus 1 is equal to 2. 2 is an even number, so we have positive sign. After deleting the row and the column in which the element is present, we are left with element 5. Cofactor of A12, element present in the first row and second column, that is 3. 1 plus 2 is 3. 3 is an odd number, so its positional sign will be minus. After deleting the row and a column in which the element is present, we are left with element 2. So this is the cofactor of A12. Next, cofactor of A21, element present in the second row and first column, so it is 2. What about its positional sign? 2 plus 1 is equal to 3. 3 is an odd number, so we have negative sign. Deleting the row and the column in which the element 2 is present, we are left with element 3. Next, cofactor of A22, element present in the second row and second column. Second row and second column, the element is 5. What about its positional sign? 2 plus 2 is equal to 4. 4 is an even number, so we have positive sign. After deleting the row and the column in which the element is present, that is element 5 in this case, we are left with 4. So we have found out the cofactors of all the elements of matrix A. Now we are going to list it in a cofactor matrix. So we are going to list row wise. Cofactor of A11 is 5. Cofactor of A12 is minus 2. Cofactor of A21 is minus 3. Cofactor of A22 is 4. So we have completed the second step. The third step involves finding the adjoint matrix of A. Now, or adjoint A. What is adjoint matrix? Adjoint matrix of A is the transpose of the cofactor matrix of A. How do we find the transpose of a given matrix? The transpose of a matrix is found out by interchanging the rows into columns or the columns into rows. So let us interchange the first row into first column and second row into second column. So 5 minus 2 minus 3 4. So we have completed the third step, which is finding the adjoint matrix of A. So the last step in finding the inverse of matrix involves dividing the adjoint matrix of A by the determinant of matrix A. So what is the determinant? The determinant is 14. So let us substitute out here 1 by 14. So this is the adjoint matrix. Let me simply copy and paste. We need to rewrite again. So finally this is our adjoint matrix, but we have not completed yet. The problem which they have given us is the simultaneous equations, and they have to ask us to find its solutions. Now this is the matrix inversion formula. X is equal to A inverse times D. A inverse we have just found out, which is this. Now what is D? D is the constant term vector, which is this one. Let us substitute A inverse and vector D in the matrix inversion formula. So A inverse is equal to 1 by 14 times this matrix. So after substituting A inverse, which is this, and constant term, which is this vector, we are going to simplify further. In the simplification process, we are going to leave this scalar as it is, and we are going to multiply this matrix of 2 by 2 order with this vector. So let us do. We know the multiplication process. This is the first matrix is of 2 by 2 order. The second matrix is of 2 by 1, that is 2 row and 1 column. So we see that the number of column in the first matrix is equal to the number of rows in the second matrix. So multiplication of these two matrices is possible, and the resulting matrix which we will get will have the dimension of 2 rows and 1 column. Five times 28 plus minus 3 times 42. So I'm going to keep minus 3 within bracket times 42. Next, second row with the vector minus 2 times 28 plus 4 times 42. Let us simplify further. 5 times 28 is 140, plus into minus is minus. 3 times 42 is 126. Next, minus into plus is minus 56, plus 4 times 42 is equal to 168. Let us simplify further. 140 minus 126 equal 14. We can use your calculator. 168 minus 56 is equal to 112. In the next step, you can multiply this number with each element inside the vector. 1 by 14 times 14, 1 by 14 times 112. 14 times 1, 14 times 1, 14 times 1 equal 14, 14 times 8 equal 112. So I'll get 1 out here and 8. So this is our answer. Finally, you will write down, therefore, x is equal to 1 and y is equal to 8. When you substitute x is equal to 1 and y is equal to 8 in the first and second equation, you will find that the left hand side is equal to the right hand side. So in this way, a common solution is found where when you substitute the solutions or the values of the variables in any of the equations, whether it is in the first equation or whether it is in the second equation, the left hand side will always be equal to the right hand side.